I welcome all participants and presenters to the today's session, Reclaim, Recycle and Recover. It's a session of 1 hour, and the challenge is we want to discuss about is if we have big ambitions in for the future, what can we do and what is needed to make this goals a reality. This is where we want to discuss about. And my name is André Strucker. I'm the moderator of this session. And if you can go to the next slide, then I can introduce myself a bit more because I want to make a change, and that's why I'm here. And I want to become the next Minister of New Economy in the Netherlands. I don't think it will work because I'm not a member of a political party, but I want to show people around the globe that we need to do something if we are really serious about what's happening with this globe. Next slide, please. Um, Urgency is needed. That's the system chase. I will introduce this in a few minutes. Then we start with a case study of AquaMinerals by Aalke, Lida, Jong. Then Jean-Pierre from SIAP will give the floor. Then Gurdev Singh from Singapore, he will give his inspirational presentation about this subject. And then a panel discussion from an EU perspective, which will be introduced by Dieter Staat. And finally, before 1 o'clock, we will end with a short summary. Next slide, please. I will not go into detail, but what you see here is that we have there's a lot of things going on, talking about Earth Overshoot Day, the planetary boundaries, we would try also to bring the social aspects into account by, for example, the donut economy, but also look at the IPCC climate change new documentary, and the COP26, which is going on. So, and not forgotten the SDGs. There's a lot of things are coming together. Next slide, please. And we at Waternet, we are doing also a lot of things, but we see that it's difficult to bring it to the next phase. For example, we upgraded some waste streams. But to bring Struvite further, it's very difficult. And Aalke, Lida, Jong will talk about this in a few moments. But also Bintel upgraded sludge into bitumen and biochar. But what we see is that they can't find investors to go from TRL 5 to 7. So yeah, and we have not yet succeeded in integrating sustainability in our work process. So also we have to look at ourselves as well. For me, the conclusion at the moment is we make nice progresses, but these are not really going to help. So my conclusion is it has to be bigger and totally different. So that is the challenge we will have today. Next slide, please. So looking at the future to become 100% circular, I hope the next speakers will focus on this point as well. Next slide, please. And having said this, I will give the floor now to Aalke, Lida, Jong. She's working for AquaMinerals. AquaMinerals is a shared company of the Dutch drinking water companies and a number of water boards. And AquaMinerals brings the residuals and recovered resources to the market. And Aalke is responsible for the sustainability and compliance issues like end waste for recovered resources. And as such, she's involved in the end of waste procedures for Struvite and cellulose. So Aalke, please take the floor.
Yeah, thanks, André. Hello to you all. Well, when we bring secondary resources to the market, we have to compete with virgin materials. Virgin materials have a huge advantage on price, on quality, legal, product status, and many years of experience. So there are many challenges, like André also said. I will focus on the challenge of getting rid of the waste status. This is Marta. Marta wants to dispose her nutrient-rich waste on the land. So what do you think? Is this allowed? Well, yes, of course. Manure is admitted as a fertilizer also over the world. It doesn't matter whether it's a waste or not. And this is Lucas. Lucas is a farmer. He wants to use Struvite as a fertilizer on his Dutch farm. Is he allowed to do so? Well, in the Netherlands, yes, since 2015. As soon as the water boards got into phosphorus recovery, they asked the Department of Agriculture for admission as a fertilizer. But in many other EU countries, Struvite is not admitted yet. Oh. This is Alex from Waternet. He's one of the Dutch Struvite founding fathers. It turned out that the farmers in the Netherlands don't want Struvite because there is already a phosphorus surplus. But fertilizer manufacturers are interested. So may Alex sell his Struvite to fertilizer manufacturer ICL in Amsterdam? Of course you say it's allowed as a fertilizer. Now that's correct, but most facilities don't have a permit to process waste. So the question is Struvite a waste or not? As you probably know, everything that's recovered from waste or wastewater is considered a waste until proven otherwise. There are European end-of-waste criteria that require a market demand, compliance with all relevant regulations, and overall there should be no negative effects on humans or the environment. There are several routes to end-of-waste. First, the EU can set criteria on a European level. Recovered phosphates, biochar and ash will be added into the new fertilizer regulation that will come into force next year. All fertilizers that acquire a CE mark will automatically lose their eventual waste status. But the raw Struvite stays, however, waste until it's proven different. The second route is national criteria. The other options are case by case. Competent authorities can decide whether a substance is a waste or not. In the Netherlands, we have a whopping 29 regional competent authorities. End of waste in one region is no guarantee for others. In the Netherlands, you can also ask the national government for a legal opinion if something is a waste or not. And the last option is to trade based on self-assessment. This requires braveness because there is no legal certainty. An inspector might not agree and start law enforcement, in which case the judge will make the final decision. Still, this is an option if the recovered material is safe and no discussion is expected, or if the material is already accepted without a formal end-of-waste process, like for instance biogas. No one is asking questions about that. Then I come to the Struvite case. In 2015, the Dutch water boards faced the problem that they had recovered Struvite, but no formal permission to sell it to interested customers like ICL. So what to do? Throw away the precious phosphorus? Yeah, no way. So we had done our homework very well, had assessed the quality and risks, and Struvite was already admitted as a fertilizer. So we took the risk and started to trade based on our own assessment. In the meantime, the water boards asked the Ministry of Environment for a national end-of-waste regulation for all recovered resources from wastewater. But that was one bridge too far. First, they wanted to try a legal opinion for Struvite, just to get a feel for it. Well, we thought piece of cake. But soon the assessors of the dossier ran into a lack of norms and rules for pharmaceuticals and pathogens. We had investigated them, but how to judge the results? Then the National Environmental Institution came into play for advice. They were just developing an approach for the assessment of the risk of recovered materials, so Struvite became a test case. First, we had to do more analysis, a lot more analysis. And this process took very long. We had insufficient budget and time, difficult to find qualified laboratory, validated matrix. There were several sample rounds. We lost samples, and finally there was Corona. But the outcome of the risk assessment now is that pharmaceuticals are no issue, but pathogens have to be managed. In order to reduce the possible risk, we will store Struvite about 1 month before we deliver it to a customer. In this time, non-spore forming bacteria like E. coli are eliminated. Well, we expect to have this legal opinion and finally, after 6 years, end of this year. When I zoom out to other European countries, I still see very little end of waste for Struvite. A couple of case-based decisions in the UK, Belgium, Denmark, and Germany. Interesting is that pharmaceuticals and pathogens have not been an issue in these cases, neither in the Struvite advice. So it makes me wonder how the risk assessment is approached in other countries and what we might learn from them. Some lessons and observations from our process. This process took too long and is far too difficult for an average company. I'm involved also in some other end of waste procedures, and there we see exactly the same. The main reason is the risk assessment. Wastewater contains all kinds of substances of very high concern, pharmaceuticals, pathogens, for which we don't have clear norms, and also risk evaluation methods are still under development. Oh, yeah. Recovered resources are judged much stricter than primary materials. This fourth end of waste criteria, that there should be overall no adverse effect on environment and human health, is explained as how do you say this? A negligible risk, but actually would leave room to weigh the environmental benefits of secondary raw materials against the benefits. For example, the risk of cadmium in rock phosphate and negative effects of mining versus the risk of pharmaceuticals in struvite. Now, the underlying problem is that we are scared for waste as a society. It's a heavy responsibility to justify that the recovered material is safe, and authorities are reluctant to take that responsibility. And last but not least, we should also look for ourselves as wastewater companies. We are recovering resources on a water treatment plant where the people are not used to make products. So people think really easy about making a product and have little motivation for quality management. And that's something we really have to work on in order to deliver trustable products. It might be useful or maybe even necessary to develop industry standards for recovered resources from wastewater. That would also help authorities to assess these materials for end of waste. A little outlook. Based on these experiences from this case study, the Dutch minister is going to make a national end of waste regulation for struvite and vivianite. It should cover all producers and all applications. We are really happy about that, but this is only a start. Because for the coming 5 years, the Dutch wastewater companies expect to start recovery of about 18 different materials, like nitrogen, bioplastics, cellulose, and reclaimed water. We need end of waste for most of these materials. And companies will not invest in recovery if there's no market. In the struvite business case, the sales of struvite is of minor importance. The gain is operational benefits. But I'm also involved in, for example, end of waste for cellulose, and that's a different story. This requires big investments in a facility to process the raw screens to cellulose. And of course, these investors want to be sure that they can sell the product. Well, the EU Commission and also here, the Dutch government are working on solutions to make it easier. Dieter will talk more about that. The circular economy ambition for 2030 already is to cut the use of primary resources with 50%. That means many materials that we now consider waste have to become a product and reach end of waste. And if we want the circular economy forward, we have to speed things up and get out of this pioneering stage. You have to create legal certainty about the product status, open the borders for secondary resources, and have positive incentives both for the recovery and the use of secondary materials in order to close this gap with the virgin materials. Thank you.
Thank you, Aalke, for giving an insight in the work you are doing and the struggles you have. You in one of the last slides, you mentioned also the very simple words, open the borders. Can you explain more what you mean by this? And also take into account, can we, at first I thought maybe it's easy to do this on a national level, but open the borders, that means you want to make it, combine it with, to create a bigger level playing field. Is this on an EU level, or what do you mean by this?
Yeah, it's exactly like you said, on a EU level. The market for secondary resources is not national, it's European or even worldwide. And an end of waste status in one country doesn't mean it's end of waste in another country. And if you want to do cross-border trades in all involved countries, it has to be considered not a waste. One solution for this is European end of waste criteria. I guess Dieter will tell more about this. Or mutual agreements in between two countries, but these I don't see them at the moment.
Okay, and why is it different in the different countries?
Well, every country is making its own assessment and having its different. I mean, the European end of waste criteria are the same in every country, but every country is addressing this procedure in a different way. Like in the Netherlands, we can do self-assessment. In most countries, it's not allowed.
Okay, thank you very much. If there are more questions, please mention them in the chat or in the Q&A. You can do it also right now. If you have also some questions for Aalke, she can answer these in the via the Q&A or the chat, or we can bring this in the panel discussion later on. Well, thank you, Aalke, for giving us this the challenge you're facing with. For now, I would like to give the floor to Jean-Pierre Tabuchi. Jean-Pierre works for the strategy department of SIAP, the bigger water authority, I think, of the Paris region. I know Jean-Pierre as one of the swimmers, one of the few swimmers in the Dutch canals. He did this a few years ago, and his ambition is, I don't know if your ambition is to swim the triathlon, but you were here to see how it is if a city swim like we have in Amsterdam is also possible in Paris, right?
Yeah, thank you.
Take the floor, and I'm very interested in your presentation and the French perspective.
I will give you some perspectives about resource recovery stakes in Paris region. So how can I change the slide? Next slide, please. So you can the SIAP is a public utility for sanitation of the Greater Paris region, and you can go to the next animation. Thank you. And the next one. So the collection area is about 1,800 square kilometers, and there are 9.2 million inhabitants and 287 cities. Next slide, please. So we own and operate 6 wastewater treatment plants, and we are in charge of the final transport of the sewage, 2.4 million cubic meters per day, and the total capacity of our treatment plant is around about 10 million PE and 2.7 million cubic meters per day. So that's just to give you a broad overview. Then next slide, please. Then when we are thinking about circular economy, the main stake is about sludge treatment and recovery from biogas and phosphorus. So we have 3 treatment plants with biogas production. So we produced 85 million cubic meters per year of biogas. And we have 3 treatment plants with incinerators, and that will be one of the stakes of the future with biogas. Next slide, please. Next slide. So what is the current destination for the sludge currently? So we have 60% of our sludge which are going to land farming for agricultural valorizations. It means that for the phosphorus, that 60% of our phosphorus is going to the agriculture. 30% of the sludge production are currently incinerated, and this phosphorus is loose for agriculture currently. One of the stakes that we have to face in the next years is about the methane production, because in France it is allowed to inject methane from biogas into the public grids. But to go onto this way, we have to shift the sludge management and to, in fact, incinerate all our sludge production. And it's also ask a question about what is going to become for the phosphorus. Next slide, please. And just to give you some order of magnitude, if you want to, we want to speak about circular economy and climate change mitigation. The first thing that I want to highlight is about phosphorus. Now, first, carbon. So, if we are looking for carbon to feed one people, we are using 230 grams of carbon per day, and only 12 grams of it is going to the sanitation system, because of the carbon that we eat is in fact going to the atmosphere through breathing. But for phosphorus, it's different. In fact, if we eat 1.5 gram of phosphorus per day, and to the sanitation system, we release 1.4 gram per day. And if we compare to the national consumption of phosphorus, in France, we use 8 gram per day per equivalent person. That is for agriculture. So it means that the phosphorus from the feces and the urine is 20% of the needs. And if we go into the Paris region, we can provide enough phosphorus from sanitation to satisfy the demand of phosphorus for Île-de-France region needs. And if we are talking about nitrogen, nitrogen from urine, in the case of Île-de-France region, which is around Paris, we collect nearly 200% of the needs of the needs for agriculture. So there are two stakes here about nitrogen and phosphorus recovery, and in the end, this stake seems to be more important than final energy recovery from the wastewater and even from greenhouse gas emission. And one point is important to notice is that emission factor of nitrogen fertilizer is 5.3 equivalent CO2 emission, so that we have to put in face of the nitrogen from urine. Next slide, please. So we have supported a research program in order to have an outlook about new paradigms in sanitation. And in this research program, the PhD student made a global mass balance of the nitrogen cycle in Paris region, including the upstream of the upstream's needs of nitrogen to produce aliment and foods, and what this nitrogen is becoming after sanitation. So you can see that I don't know if you don't see so the needs for 1 year for one person is nearly 5 kilograms of nitrogen per person, and the excretate is roughly the same quantity of nitrogen which goes to the treatment plant. And the treatment plant is managing nitrogen by transform the nitrogen to N2, which go to the atmosphere, and that costs money, that costs energy, and really little of nitrogen which is going back to the field. So a lot of losses of nitrogen. If we just change the next slide, please. So if we change of the model of sanitation, but also if we change our habits in terms of feeding. So if we reduce by half our meat consumption, and if we collect half of the urine that is produced in the Paris region, we will not need fertilizer to feed the people. So it's a big change in terms of environmental impact. Next slide, please. And if we couple the nitrogen separate collection with anaerobic treatment of carbon with a separate collection of feces, then we will not need any more energy also to oxidize the carbon. So I will not go into the detail, but during this research program, we also had a life cycle analysis of urine-based fertilizer. And next slide, please. So the student has been working on several different kind of ways of collecting and transform urine to fertilizer. But in all cases, even if we evaporate water from urine, the benefit for climate change impact is far for the urine collection. Next slide, please. Thank you. So now if we move to the phosphorus, so it's the same scheme. A lot of the phosphorus that is used for fertilizing is for meat production, like for the nitrogen, and only a very little of phosphorus from meat is coming to the food. And in the end, so the one Parisian citizen eats 0.40 kilogram of phosphorus per year, and most of it is released in the excretate to the sewage treatment plant. And this phosphorus is going to the land for 60%, as I said before. So one of the challenge in the future for the SIAP, next slide, please, is so because the question is about if we are going to incinerate or not our sludge. So the main question is if we incinerate our sludge is to recover phosphorus from the ashes. And then we had an intern who worked last summer about phosphorus recovery, and we found that there are 10 companies or processes that are on the market or are under studies to recover sludge from phosphorus from sludge. And there are 14 companies or processes that are working on phosphorus recovery from ashes. And 10 of them are wet processing, and 4 of them are dry processing. And among all of these, we can see that phosphorus is not in the field of sanitation skills, so it's a new work for us, and we don't know it. So we have and the second thing is that we, like energy, phosphorus has a value market, yes, and that is also a change in the approach for public utilities. And I think that we found that the example of what's happened in Hamburg is quite interesting, because they are setting up a semi-public company in a partnership with Remondis in order to recover phosphorus from ashes. And Remondis will be in charge of the commercialization of the phosphorus. And so we are looking forward what it is going to happen there. Next slide, please. The time is running. So with the circular economy, and in fact, energy and as well as greenhouse gas is not a key stakes for sanitation, but as a public utility, we have to contribute to the climate change mitigation. But what it is happened with the phosphorus recovery, it is easy to meet to the challenge of sustainable phosphorus management. And it is easy also, in fact, between coasts to implement a strategy of phosphorus recovery compared to nitrogen, in fact, because nitrogen you need to go to separate urine collection. What can I say? And we also have to keep in mind that the link between food and sanitation is very strong, and we have to think the whole process, in fact, and the whole cycle. And of course, as Aalke said, we have regulation limits, but on both on nitrogen and phosphorus, but more on nitrogen, I think that it is a radical change that would help to meet our urgency needs, as you said, André. Thank you for listening.
Thank you, Jean-Pierre, for giving the insights and this change thinking of how you can connect waste streams with other chains like the food chain. What do you foresee as the next steps for?
So the next steps, there is a big. Currently, there are a lot of people who are starting a pilot and more than pilot experience in urine diversion in Paris, but also in other large cities in France. And that is really exciting to see that people are going on this way. And of course, for STIAP directly, what is going to happen with our sludge treatment rebuilding, it's a really big challenge, and depending on our choice, they will be fixed for the next 30 years. So it's important to choose the good way right now.
Okay, thank you very much. If there are some questions for Jean-Pierre, please let us know in the chat or in the Q&A, or otherwise. Jean-Pierre, if you look at the European dimension, what would your question be to Dieter if you look at your presentation you give?
Okay. But we have the same problem as you, Aalke. It's a question of regulation because urine is a waste, and if we want to mix urine with other waste, currently it is forbidden in France. So that is one of the problems that we have to face currently.
Yeah. And I see also a question of Jan-Peter. I think this is very interesting to bring in the discussion later on. I see a question, Jean-Pierre, for you from Martot. Can you give some examples of those initiatives? And I think can you give some examples of the initiatives you mentioned?
Yeah. So, for example, in Paris, there is a new development area in Paris City. And this new development area is settled with separate urine collection and with a local urine conditioning in order to produce fertilizer. I think it's about 8,000 people who will live there. So that is more than a pilot experience, and it is ongoing. In Bordeaux city also. It's not only wine, it's also there is a ongoing process to collect feces from dry toilets and to use it as a fertilizer. In Brittany, there are also a project which is now nearly finished. So big enthusiasm for urine collection.
Okay, thank you very much, Jean-Pierre. In the Netherlands, we try to do this at Strand Island, a new build. I think it was also for 8,000 houses. but this was very difficult to realize because you have also to make the connection with the houses, and there are different rules in the houses as they are in the public space.
And what is difficult too, in fact, if we are speaking about urine collection, so it's a new business model that we have to set up to collect the urine and to condition it to make it usable for fertilizing and so on. So there are a lot of challenges, in fact. But I think it's relevant in front of the challenge that we have to face for the climate change and the circular economy.
Yeah, and to exchange this knowledge between utility companies or knowledge institute or wherever. Thank you very much, Jean-Pierre, for your for your presentation and answering the questions. I would like to go to Gurdev Singh from the Public Utility of Singapore. Gurdev, you are the Deputy Director Technology Department at Singapore, Singapore's National Water Agency. You are organizing also every 2 years the Singapore International Water Week, and I think this will be next year as well. We met each other a few years ago, and then we talked about the strategy issues and the vision from how to tackle the bigger problems if you look at more on a metropolitan level. And yeah, maybe you will go into this in the coming slides. I'm very interested in your opinion, and then I think it will be more from the CO2 emission impact, I think, right? Please go ahead.
That's right. Thank you, Andre. And it's really a great pleasure for me to be here. Thank you for inviting me for this session. So I'll change tracks a little bit, and I'll be speaking about greenhouse gas emissions, a topic that is high on the global agenda, and the quest within PUB, which is obviously, as you've introduced, Singapore's National Water Agency, to get to net zero emissions. Next slide, please. So in PUB's operations, there are 3 key outcomes we aim for in our water system. The water system is shown as the loop in the middle with the diagram there. The first essentially is adequacy, the second is resilience, and the third is sustainability. Now, if any one of these outcomes is not achieved, the water system will be unbalanced and ultimately fail. About 2 decades ago, we closed the water loop in Singapore through new water. This is the high-grade recycled water from domestic wastewater, or used water as we call it in Singapore. What this means is that every drop of used water in Singapore is collected, processed, and made into high-quality grade water for reuse to meet our demand in industry or consumption through indirect potable use. In addition to new water, we have added desalination to strengthen our adequacy and also resilience, as both new water and desalinated water are less climate-dependent sources of water that we can tap on even when natural water sources are affected. Although we have closed the water loop, these new sources come at the expense of higher energy and waste streams that need to be closed. In Singapore's context, energy means higher carbon emissions, as more than 95% of our energy needs come from fossil fuels, which are imported. To be sustainable, we need to close the waste and carbon loop. For today's presentation, obviously, I'll be focusing on closing the carbon loop. Next slide, please. To better understand Singapore and its constraints, I've put together some data on Singapore and compared it with Netherlands, which many of you will be familiar with. Singapore is significantly smaller, about 58 times smaller than the Netherlands. And on this little island, which is densely packed, as you can see from the population density per square kilometer, there is much competition for resources. And the challenge is that Singapore is very short on natural resources of its own. What's interesting is that although Netherlands' greenhouse gas emissions are slightly higher, about 3 to 4 times higher than Singapore's on a total emission basis, in the figure on the left, in the last decade, Netherlands' emissions have in fact been coming down, but Singapore's have been increasing, and that's pretty alarming for us. By other normalized measures, greenhouse gas per capita or GDP as shown in the next 2 charts, the numbers are similar for both countries. But a big differentiating factor is the potential for Netherlands to go green through renewables. It's significantly higher potential compared to Singapore. Already more than 10% of energy in the Netherlands is derived from renewables, whereas it is less than 1% in Singapore. Obviously, we have an ambition in Singapore to increase our renewable energy mix, but there are limitations. Amongst the publicly acceptable forms of renewable energy, only solar is the most feasible in Singapore. Our wind speeds are too low for wind energy. Our surrounding seas are crowded with shipping and too calm for tidal, and we have no hydroelectric or non-geothermal energy sources. As such, the upper limit of solar deployment in small, densely packed Singapore is limited to around 5% of the energy mix. So getting to net zero is a significant challenge and a very big challenge for us. Next slide, please. I won't dwell too much on this slide. It shows Singapore's greenhouse gas emissions and breakdown by sectors. As Jean-Pierre pointed out, the key point is that the water and wastewater sector is actually a small contributor of greenhouse gas emissions by industry type. In Singapore, it is less than 1.5% of Singapore's emissions. But we also note that with rising water demand, we expect our emissions to increase in future. And actually, the needle mover is that we are expecting the cost of carbon to go up as the world needs to urgently find levers to control emissions. With Singapore's situation, this is not sustainable for us as a utility in the long run. So we have to do something about it today. Now, next slide. Therefore, next slide, please. So therefore, we have put in place a framework to guide our efforts to get to net zero. This involves 3 pillars. First is about trimming the fat, looking at where we can leverage technology and digitalization to reduce emissions where possible. The second pillar is about finding innovative ways to incorporate renewables despite our limitations. And ultimately, the third area is a completely new area for us, and it's one of the areas that I'm most excited about, is how do we remove emissions from the environment altogether and do that as a water utility. I will cover each of these with more info in the subsequent slides. Now, the next slide. The first area on reducing emissions. Desalination is our most energy-intensive water drop at the moment. Each cubic meter of desalinated water emits around 1.4 kilograms of CO2. We have an ambition to lower the desalination energy requirements to less than 2 kilowatt-hour per meter cube in the coming years from the current 3.5. There are several projects ongoing on this front at various stages of R&D and deployment. I won't go into the details of each, but you can obviously come and speak to me. I will be interested to hear if you have further ideas beyond what we are exploring. The next slide. Another needle mover is how to reduce the energy requirements of used water treatment while allowing for biogenically produced energy from used water. Our ultimate goal is to produce all the energy required to power used water treatment plants without taking energy from the grid, or in Singapore's case, fossil fuels. Again, there are several projects being explored here to not just push the boundary on this front, but also look at technologies that minimize the waste produced and maximize the resources that can be recovered. Next slide, please. Thirdly, it's about managing demand. We are rolling out several initiatives such as smart metering and water-efficient devices in homes to bring our domestic demand down. Our goal is to bring our domestic LPCD, or liters per capita per day, to 130 by 2030. The less we consume, the less water we need, and obviously the less waste we produce, and correspondingly the less carbon emissions. We are also pushing the boundaries in terms of recycling within the industry so that we have to provide less water demand to the industries. Now, the next slide, please. So our projections indicate that even as we push the boundaries on these areas and implement the measures in the years ahead in terms of reducing emissions, these will only remove around 40% of our projected greenhouse gas emissions by mid-century. We will need to do more to obviously close the carbon loop, and I will touch on the second pillar where replace with renewables comes in to give us an added push. Next slide, please. So PUB has been an early adopter of solar energy. We have implemented solar energy on all eligible buildings in our infrastructure, from our admin buildings to pumping stations to rooftops of various plants. But beyond this, as we will see in the next slide, we have to find new ways to deploy solar. So next slide, please. We have now moved from R&D to deployment on the use of solar panels as floating solar on our reservoirs after various studies and research programs starting from 2015, as well as environmental studies and consultations that were done during this period. Just this year in May, we operationalized the Tenge floating solar farm, which is shown in the bottom right picture. This is a 60 megawatt peak system, and it ensures that all our waterworks can effectively run on solar energy. We intend to expand further, obviously balancing the recreational needs of our reservoirs and biodiversity to increase our floating solar capacity. Next slide, please. But however, due to limitations of space and competing needs, doing this will eliminate only a further 20% of our carbon emissions by mid-century, as shown in the next slide. So even with the first two pillars, we cannot close the carbon loop and will be short of around 0.4 million tons or 400 kilotons of CO2 equivalent per year by mid-century. So we challenge ourselves this year to find alternative ways to close the carbon loop, and these include removing CO2 from the environment through our facilities, both the direct as well as indirect emissions. Next slide, please. So this is a very early area for us, and we have now embarked on two projects. The first is we are looking at carbon capture and utilization solutions. So the first project aims to remove CO2 from seawater in a process that potentially can be integrated with our desalination plants. And the second project is to study various scenarios to capture CO2 from the biogas in used water treatment and mix it with other waste streams to produce construction materials. As I mentioned, this is a new area, but an exciting one, as it allows us to imagine our treatment plants not just as water production facilities, but also potential carbon removal facilities as well. We are very excited about this area, and we are actually going global to seek breakthroughs and solutions that could be integrated with our operations to achieve this. So next slide. So this is kind of hot off the press. In the last 2 weeks, just 2 weeks ago, actually, we launched our Carbon Zero Grand Challenge to explore solutions that could help PUB get to net zero. We're looking for solutions beyond the areas we are working on. In particular, we're most interested in the solutions that could provide net negative CO2 removal through carbon capture, which could be integrated as part of our operations. These solutions will obviously have to make techno-economic sense and operational sense for us to invest in. And while we intend to close the carbon loop, it should not adversely affect the water loop, and if possible, enhance our efforts further to close the waste loop as well. The challenge has a total fund size of about $6.5 million, and more details can be found in the challenge website in the QR code and link provided. There's also a link to find us on LinkedIn if you want to find out the latest on this and other global challenges that we launch from time to time. So with that, I have come to the end of my slides, and my last slide really is what Andre started off with, SIWW. I mean, my last slide is really about enjoy the rest of the Amsterdam International Water Week, and we look forward to welcoming you in Singapore International Water Week next year, which is in April. So book your tickets and hope to see you there in person.
Thank you very much, Gurdev, for your presentation and the ambition you have as Singapore to become carbon neutral. The question I have, if I may, you are closing the gap by looking for the challenges. For you ask to come with new solutions. You are looking for solutions which are already commercial available, or are you looking also for solutions which are not ready on the market, already on the market?
Yes, so we're open to both kinds of solutions, but our ambition really is that we want a solution that we can integrate within our operations within the next decade. So we are all racing against time. So the kind of if I may, the ambition or the outcome we hope is that it's something that we can demonstrate within the next decade that we can put into our plants subsequently.
Yeah. Okay. And you're talking about technical solutions. Do you see also that there are limits within the current system, or do you see some limits because of the current legislation?
So that's a quite a loaded question as well. I think certainly for us, what we're really after is the game-changing solutions that can transform the way we work and operate, and essentially we will try to reduce these hurdles as much as possible when it comes to legislation as well as other hurdles that may arise, such as economic systems and so on. So that the key point is that let's start with the technical solution first. Let's make sure it makes sense, and then we, while we are doing that, we identify where are the challenges, and we try to address them step by step, as we have done in many of our other projects that we have implemented over the years.
Okay, thank you very much, Gurdev, for giving some insights of the Singapore mission. I think we have 10 minutes left, almost 10 minutes left for giving this overview and have a kind of a panel discussion. I would like to give the floor to Dieter, but please join the discussion if you like, and bring in your ideas or your questions you have. Dieter, you have listened to the presenters, you have listened to the challenges, and before we'll give you the floor, I will introduce you a bit. You are permanently working and living in Brussels, right, where you are presenting the interests of the Dutch water authorities and the Dutch water companies. And since 2016, you are also lobbying on the water-related EU legislation. And also you have a close contact with EU decision makers at the European Commission, Council and European Parliament. Having said this, if you look at what is now presented, could you give your perspective from an EU side?
Yeah, sure. What I heard today is actually really closely connected to everything that is happening on the European level at the moment. So that's quite encouraging. And especially, it's also nice to see that you are focusing on the resource recovery and on energy/greenhouse gases side, because I believe you cannot see them separated from each other. And also in Brussels, both of them are very much in the picture. I really liked the comment that Jean-Pierre van der Hoek made in the chat, that it is important to upscale things if you really want to have a true circular economy. And even though I'm very happy with the initiative that the Dutch government takes when it comes to end-of-waste status for example, Struvite, I believe that we need European action and a European legal framework that is enhancing the circularity of the water sector. So we need to go bigger, and of course, totally international would even be better, but we have to start somewhere, right? So yeah, upscaling is my first point, and for upscaling you need the European Union, and you need European legislation that is promoting this circularity and helps the water sector to make this transition. With the European Green Deal, we really have momentum at the moment with the zero pollution ambition and the climate neutrality goals and the circular ambitions that are also part of this Green Deal. So in a way, that's really good. Also, the focus on zero pollution means that we will get better source control because what Aalke also mentioned, that in our input materials, there are sometimes some not really good things that are in there, like pathogens. But if we have European policies that are controlling emissions of pathogens, for example, and chemicals, then it would be easier to reuse our resources from in the wastewater cycle. So source control is a very important point, and source control has to come from the European level. Another development that is happening at the moment is the revision of the Urban Wastewater Treatment Directive. This is for European water operators, the legislation that sets the minimum requirements for the treatment of wastewater. And the European Commission will come with a proposal to revise this legislation next year. And at the moment, they are working on the revision proposal. So they're trying to come with as many proposals to make the future legislation more future-proof. And they don't only want to look anymore at the treatment itself, but they're also looking into what they can make for new requirements for energy recovery, energy efficiency, and energy audits compulsory for water operators, and also resource recovery. I have to say that until now it's mainly phosphorus where the Commission is focusing on, but the Commission, I asked the Commission last week, are you only focusing on phosphorus, or are you also checking the other resources potential? And then they say, of course, we also look at the rest, but let's see what the Commission will come with next June. But phosphorus is the main resource that is now in focus. Aalke mentioned the European end of waste status. I think that's a very important one. So, of course, we have the Urban Wastewater Treatment Directive that sets the standards and forces the water operators also to recover. But then without the end of waste status, the real market will never come, because then the operators will still struggle to be able to trade, for example, their resources cross-border inside Europe. So if all the national governments are still making their own end of waste status, then we will never get this European market. So as a water sector in Brussels, this is one of our priorities when it comes to circular economy. So we really are trying to influence the European Commission by coming up with really concrete actions to develop end-of-waste status for sludge and wastewater. And yeah, I can talk for ages about that, but I won't do that. But it's at least important for you to know that these initiatives are taking place and that our European associations are really active in that. But it is to see what the Commission will do with that. That's of course, we can do our thing, but of course the policymakers and decision makers needs to take action as well. That in short, my reaction.
Thank you very much, Dieter, for giving this reflection on it. I have a question for Gurdev. If you hear Dieter talking about this bigger market of a few hundred million people, Singapore has almost 6 million people. What do you think? Are they of another planet, or it's very easy to do this on a smaller scale, so you can control this better?
I think the issues that we can control internally, we can do that, but there are global issues, of course, that are a lot harder. The challenges that we have with waste are very similar to what has been described today. We have issues with cross-border, because in Singapore we hardly have an agricultural industry. Where's the market for such waste, and how is waste classified when we have to ship it across transboundary regions and so on? We have the same issues related to standards, and we're trying to now build standards around how waste, incinerated ash, could be incorporated into construction materials and so on. There aren't standards there, and I think there is a great development that needs to be done there. So these are sometimes issues that we can control within our areas, but obviously there are cross-boundary and cross-geographical issues which are a lot harder to control. I think what Singapore has shown and done well in the past is that, in general, when there's a national agenda set, the entire system moves in that direction. That's one. And now the national agenda is moving towards sustainability very strongly, and that's an area that we want to move into. The second is that we find ways to integrate. So, for example, closing the water loop came about because PUB had full control of used water as well as drinking water, and we could see that linkage. And now our work has expanded to look at coastal protection as well, to look at the climate change aspects and so on as well. So those are two important factors that we have in our favor. At the same time, of course, economics makes a lot of difference. Pricing the resources rightly, I think that's a very important aspect. Water in Singapore is not subsidized in that sense. It's priced to reflect its scarcity value. And I think we then have to look at the pricing models for our waste as well as carbon. And I just want to conclude by one thing by saying that I think there's an opportunity here for us to look at the trilemma of waste, carbon, and water at this point in time, and bring out the value of our breakthroughs to address all three areas and not just one. I think that will really bring us forward in terms of this area and solve our problems. Thank you.
Thank you, Gurdev, for giving this additional very inspiring information as well. And I think we have to summarize. Time is flying. For me, it's interesting. What I heard is on a EU level, we need this bigger scale. Gurdev gives some reflection on this. What you also see is that to have this bigger scale, you need to do it more maybe centralized, but on the other way, as Jean-Pierre told us, you see also some smaller scale initiatives and to do it more decentralized, local and small. So this seems to be a kind of a bit of a contradiction. This is also something we have to see how we can deal with this and how we can make it and see if this can fit into a new way of thinking, or maybe a new circular economy thinking. I would like to thank everyone for listening to the presenters. Thank you, Dieter, for giving the reflection. Thank you, Gurdev, for giving the insights from the Singapore's perspective. Thank you, Jean-Pierre, for bringing us the new sanitation aspects of the French invalshoek. And Aalke from the Dutch side. Thank you very much, all, and hope to see you soon.
See you tomorrow. Bye-bye.
Bye.
Thank you as well, André, for moderating this session. Very much appreciated.
Yeah, well job.
Thank you.
Thank you, Andre.
Great.
Thank you all.
Have a good day, everyone. Enjoy the rest of the program.
Thank you.
Dankjewel, André.